The next topic is greatest common factor and factoring. So we start with the process of distribution, and just give an example for a reminder. If we distribute the 3x squared y to the fourth in this example, we get this, and we just use the rules of exponents as we've discussed. In this section, what we want to do is actually go backwards, so we're going to be starting with something that looks like the second line here, and try to get back the first line. So the first thing we do is identify what's called the greatest common factor. So we'll do an example that focuses on just that concept of the greatest common factor. The greatest common factor of two numbers is exactly the largest number that divides both of those numbers. It's a factor, it's common between the two, and it's the largest such common factor. So we'll take this example of 2 3 squared times 5 squared and 2 squared times 3 cubed times 5. So what's the largest number that is a factor of both of those numbers? Let's look at one prime at a time. I've written these numbers conveniently in terms of the prime factorization. Let's consider first the 2. There's a factor of 2 in the first number and 2 squared in the second number. 2 divides 2 and 2 squared, but 2 squared does not divide 2. So 2 is the largest common factor of 2 and 2 squared. What about the 3? In the first number, the factor is 3 squared, and the second number, the factor we're concerned with, is 3 cubed. 3 squared divides 3 squared and 3 cubed, but 3 cubed does not divide 3 squared. So 3 squared is the largest common factor of 3 squared and 3 cubed. It's the greatest common factor. Similarly, 5 is the greatest common factor of 5 and 5 squared. So the greatest common factor of these two numbers, we'll just multiply what we found out for each prime, 2, 3, and 5. We got 2 times 3 squared times 5, which is 90. Let's do another example here. What is the greatest common factor of x squared, x cubed, and x to the fourth? Well, we see x squared is a factor of all of these three, x squared, x cubed, and x to the fourth. X cubed, however, is not a factor of x squared. Why? Because when we divide, we will get a fraction. So this involves a fraction. So, what's the answer? X squared is the greatest common factor. Increasing the exponent was not possible. Okay, what about this one? The greatest common factor of these three. We'll take the numbers first. 3, 6, and 9. The greatest common factor among those is 3. We have x squared, x cubed, and x to the fourth. The greatest common factor is x squared. For the y's, we have y to the fourth, y to the sixth, and y to the seventh. The greatest common factor there is y to the fourth. What about this one? Greatest common factor of 10x squared, y cubed, and 15x cubed times y. Let's see, 10 is 5 times 2, 15 is 3 times 5. So it looks like 5 is the only common factor of those two numbers. What about the x? We have x squared and x cubed. X squared divides both of those, but x cubed does not divide x squared. And finally, the y divides both y and y cubed, but y cubed does not divide y. And y squared does not divide y. Any higher power of y does not divide y. So y is the greatest common factor of the y part. And so the greatest common factor of those two expressions is 5x squared times y. Okay. Let's look at factoring out the greatest common factor. So this is what we were talking about at the beginning. The goal is kind of undo that distribution. So the first thing to do is to identify the greatest common factor. Here we got 3x squared y to the fourth. That was the example above. And now what does it mean to factor out? It means we want to find out what goes in that space. Or what do we need to put there so that when we distribute, we get the left-hand side. And to see, we're going to actually divide both sides by that greatest common factor. Okay, so we can distribute the division, and then we simplify the terms. We get 1 minus 2x y squared plus 3x squared y cubed. So we can go back up here. And try these out. Factor out the greatest common factor of those. Factor out the greatest common factor by first finding the greatest common factor, and then you can divide, just like we did in the example above. You might also just guess and check. Okay, this is the first example of factoring by grouping. So I've outlined the steps here, and I'm just going to demonstrate it with this example, and then we'll do another example. Okay, the first step is to group these terms in pairs. So I'll take the first two terms and the second two terms. Now, factor out the greatest common factor for each resulting binomial. So the greatest common factor of x squared and 3x is x, and we're going to factor that out. What do we get? X plus 3. You can check that by distribution. Make sure we get the x squared plus 3x. So those two things are equal. Plus 2. And then we need an x plus 3. So those two things are also equal. Now we see a common factor. So the x plus 3 is a factor of the first term. The first term is x times x plus 3. The second term is 2 times x plus 3, and x plus 3 is a factor of that as well. So that's a common factor, so we can factor it out. What do we need to multiply x plus 3 by? X plus 2. So we have factored the original expression completely. Okay, let's look at the second example. We're going to do the same thing. Step 1, group. I'm going to group this in pairs. I'm going to put the minus sign with the 18. If I don't, there's a danger I'm going to not distribute properly. So there's just a guard against error. The greatest common factor, 2x. What do we need here? A 6x plus 5. Now I'm aiming to get a 6x here, so I'm going to factor out a minus sign. What's a common factor? Negative 3. And we end up here with 6x plus 5. Check it by distribution. So what's the common factor? 6x plus 5. So we get 6x plus 5 times 2x minus 3. Okay, try this factoring by grouping question. Follow the steps. Okay,